So we're going over chapter 8, section 3, proving triangles are similar by SSS or SAS, which is side-side-side or side-angle-side. So side-side-side similarity theorem states if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So how do we prove this? Again, we're going to use the scale factor that we've been using for the last section. So if I wanted to do this, I'm going to say that this one is congruent to this one. I'm going to just name them to make it easier to see. As LL, MM, and SS. Now you don't have to. This is just so it's easier to follow along. So we have 10 and 5 will be equal to 8 and 4, which is equal to 6 and 3. Now this is all the sides. This is the proportionality statement that we have done. Now if I were to simplify any of this one simplifies to 2 over 1. This one simplifies to 2 over 1. And this one simplifies to 2 over 1. So we have the same scale factor. I'm going to change it to highlighters. We have the same scale factor for all of them. So again, this is what we've been finding, what you found on your quiz. You're going to need it all throughout these lessons. But just being able to prove that the scale factor is the same for all of them, or, well, if you found one, it would have been enough. If you would have done it the other way, it would have been fine too. You're able to say that triangle ABC is similar to triangle DEF. So the SAA similarity theorem, or side-angle-side, states that if an angle of one triangle is congruent to an angle of a second triangle, then the length of the sides, including these angles, are proportional. Then the triangles are similar. So what is this stating? This is saying that if an angle, in this case is A and D, are congruent and the one angle to the second triangle, in this case again would be A and D, it's not really, you can't really see it with these shapes. In the old PowerPoint, this was orange and we had a black line. So I'm just remarking them for you guys. Telling us that those two triangles have that congruent angle. Then the two sides next to that angle, in this case, it would be the 10 and the 5. And the 8 and the 4 are similar, assuming they have the same scale factor. Now, in this case, we don't want to assume. I'm just going to do 10 over 5. That's going to simplify again to 2 over 1. And if I do 8 over 4, it's going to simplify to 2 over 1. Since they have the same scale factor, and they're telling us that the angle is congruent, we have a similar triangle, so side, angle, side of similar side, congruent angle, similar side. We can find it again by the scale factor, so we're able to say that both triangles, in this case, triangle ABC, is similar to triangle DEF. So you guys saw a similar triangle. Now I'm going to do one that's not, so you guys understand how it works. If you have a triangle shape like that, they're telling us these two angles are congruent because they're vertical. Let's say this is 5, this is 8, this is 10, and this is 6. I'm trying to just use the similar things that we've been using before. If we find the scale factor, we're going to get a scale factor of, let's say, 5 and 10, which is going to simplify to 1 over 2. And then we can say 6 and 8, which is 3 over 4. So since they do not simplify to the same scale factor, these are not similar, even if the angle is congruent. Also, if by any chance you do have a triangle, these two are congruent, we know that. 5, 10, 8, and 4, I think were the numbers before. If I do 5 and 10, we get a half. And if I do 4 and 8, I get a half as well. So we do have the same scale factor. But this is also the type of question that is there to try and kind of trick you. This is not an included angle. So if this is not an included angle, this cannot be proven as similar by a side angle side. The included angle for these two lines would be these ones right here. Now, if they would have told us those red angles were congruent, then this would be a different story. This would be a similar triangle. But since they only told us that the vertical angles were congruent, there was no way that this would have been a similar triangle by side angle side. So this is so far a summary of what you've learned. So you have the triangle similar postulate and theorem. So you have the AA similar postulate, which are the two angles are congruent within two triangles. So if you have, let's say, angle A and angle D in this figure are congruent, and angle B and angle E are congruent, then those two triangles are similar. You have the side-side-side similarity theorem, which is the one that we did first with the proportionality, I can't say that word today, I'm so sorry, statement that you guys did on the quiz. I just didn't know that was a side-side similarity theorem. If all of the sides have the same scale factor, then those two triangles are similar, assuming they don't give you any angles. And then for this SAS similarity theorem, you have to have an included congruent angle. That is the key part right there, the included angle. And then they'll tell you AB and DE is the same scale factor as AC and DF. Now, if those three things are true, then it's similar by the SAS congruence, similarity theorem, sorry. So far, these are the only three ways that you know how to find that triangles are similar. You can use any of these three at any point to prove that they're similar. Unless I specifically say prove they're similar by this theorem, you can use whichever you think is better. So for example 1, we have two steps. Step A, or part A, is the measure of the side of the triangle ABC are 4, 5, and 7, and the measure of the sides of triangle XYZ are 16, 20, and 28. Are these triangles similar? Now, the only way I would be able to do this is if I were to draw them out. So I'm actually going to go ahead and draw them out. Please, I'm sorry if my triangles come out terrible. Obviously, they're not drawn to scale. So we have A, B, C, and X, Y, Z. So we have the sides are going to be 4, 5, 7, and 16, 20, and 28. Are these triangles similar? Now, the way to solve this is to, in this case, they don't give us any angles, so the only way you can really solve for this is to try and solve for the sides. So the side-side-side similarity theorem. So I'm going to go ahead and do the 4 over 16. That's going to simplify to 1 over 4. If I do the 5 over 20, it's going to simplify to 1 over 4. And if I do the 7 over 28, that's also going to simplify to 1 over 4. So because they all simplify to the same scale factor, we're using the side-side-side similarity theorem. I'm going to write the answer up here. Yes, they are similar. Triangle ABC is similar to triangle XYZ. Now, I do want to point out the way I drew the triangle. I drew them in the same order. If I started with A on the top, I made sure X was on the top. And if I went left for B, I went left for Y. It's the only way to make sure you draw the triangles congruent. You have to take it based on the given information. So for B, we have in triangle ABC, again, I'm just going to draw them again. Triangle ABC, we have AB is 2, AC is 5, and BC is 6. And then we have X, Y, Z. This is 2.5. YZ, XY is 2.5. YZ is 2. And XZ is 3. They want to know if the triangles are similar. Now, the only way for us to do this is to, again, use the side-side-side similarity theorem, as they don't give us any angles. So I'm going to go ahead. Since I drew it the same way as it went in the order, I'm able to say that they're going to be congruent, the left side with the left side, the base with the base, and the right side with the right side. So I'm going to go ahead and do, let's say, 2 and 2.5. In order to get rid of the 0.5, I'm going to multiply the top and the bottom by 10. So I'm going to get 20 over 25. Which is going to simplify to 4 over 5. Now I'm going to do 6 and 2, which is going to simplify to 3 over 1. I don't even have to keep going because the two scale factors that I have found already are not the same. So therefore, these are not similar triangles, so not similar. So for example 2, we have if triangle XYQ is similar to triangle XZP, does it follow that triangle XPQ is similar to XZY? Now, they're giving us a bunch of triangles within this one, so let's separate them. We have triangle XYQ, is this one right here, in yellow. And we have also triangle XZP, so it's this one right here. Those two are similar. Now they want to know if XPQ, so this one right here, XPQ, is similar to XZY, so XZY would be this big one right here. Now, the only way for us to know or be able to solve this is to have some numbers, which I'll write in some numbers to work it out. But we have that this angle is shared, so we already have the included angle. If we're able to find that this part right here and this whole part right here are similar in their ratios, then we should be more than fine. Now, the only way for us to find those ratios is by using the first two triangles that we're given, which is the yellow and the green. Now, I'm just going to draw one of the triangles first. I am sorry, this is probably not going to look at all like the picture, but it's fine. This is X, this is X. We know they all share X, so it's a congruent. We have P, we have Z, we have Q, and we have Y. We know those are similar, so I can say these are congruent, and I can say these three are congruent. Now I'm going to give them numbers. So I'm going to do 2, 4, 6, 12, and 8, 16. All I did was I did a scale factor of 2, guys. I don't know if you noticed. All I did was multiply by 2. Now, they want us to find, so when I give them these numbers, obviously you don't have to make them up. You're going to find out that this one's going to be 2, this one's going to be 4, this one's going to be 12, and this one's going to be 6, based on the drawings. Awesome. I made them similar with the scale factor, so I'm not going to worry about it too much. So with this new triangles that we're trying to find, we have X and X on the top, YZ, and PQ. The X is congruent with the X. We know this is going to be 2 and 4, and we know this is 12 and 6. But it is the 6 goes with the 2, and the 12 goes with the 4. Just like the other one. It's going based on the way that it's written, and it's written as XP and XZ should be congruent. That's why I did the red with the red and the blue with the blue. Now when I do that, I find the scale factor. So if I do 4 over 12, I'm going to get 1/3. And if I do 2 over 6, I'm still going to get 1/3. Now, because it is the same scale factor, and we have the included angle, I can say that these two triangles, so yes, these two triangles are similar by side angle, side similarity. So XPQ is similar to XZY. The key here, guys, is to kind of take it a step at a time. I know I made up the numbers for the first two triangles that are similar, but since it's given, I just multiply them by 2. And if you are redrawing stuff like I did, make sure that you follow the way it is written, like XP was similar to XZ, and that's why I ended up with the red and the red being similar, even though they're in the opposite sides of the triangle. Lastly, for example 3, they want us to name the similarity triangles and give the postulate or theorem that justifies your answer. So, we have this shared angle right here, and we have 80-80. So that means we have two congruent angles. Because we have two congruent angles, yes, this is similar by AA. So I can name the triangle ADE is similar to triangle ABC. For triangle B, we have that C is shared, so we can figure out if the big triangle is similar to the smaller one by doing the similarity, the scale factor. So this is going to be 15, this is going to be 9. So I can do 6 over 9, simplifies to 2 over 3. And I can do 10 over 15, simplifies to 2 over 3. So yes, this is similar by the side angle side similarity theorem. I'm just going to write down the triangles the way they're similar. And then the last one, we got to figure out if these two are similar. Now they're telling us that this 6 and this is 6. Actually, sorry. This one and this one will be congruent. I'm doing based on the smallest to smallest part ratio. This 10 is the second smallest, so it goes to the second smallest. And then we have the remainder 6 and 12. That is the added at the end. So since they don't give me any angles, I can actually just go ahead and solve by side. So if I do 3 over 6, it's going to simplify to 1 over 2. If I do 5 over 10, it's going to simplify to 1 over 2. And then 6 over 12. The 12 comes from the addition of this 6 and this 6, guys. This is the 12, the addition of those two. When I do that, it's going to give me also a half. So these two are similar by the side similarity theorem. So we have triangle KLM is similar to triangle KON. So that's how we found those 3 similarity theorems, or how we used all 3 of them in order to find whether the triangles were similar. Now, as I mentioned, you guys, you do have homework for tonight. But that is it for this lesson.